For question number 5 here, this is kind of encapsulating a bunch of the skills that we have learned throughout this unit. We have a titration curve, easy for you to say, of an unknown acid, and we'd like to know which of these acids it is here based upon the curve that is present. Well, before we get to any math at all, we can really reduce this to just a couple of choices based upon the midpoint and the pKa alone. So with no other information that we're given and without even having to pick up a calculator, we know that your equivalence point is here at a pH of, or at a volume of about 20 milliliters. That's your equivalence point. So if we cut that in half and go to 10, that's where your midpoint is. And armed with no other information besides this, the midpoint is where the pH is equal to your pKa. So if we shoot over here, we can see that the midpoint is in the high 4 approaching 5 kind of zone. So right off the bat, we can eliminate hypobromous acid and phenol as possibilities from there. It's got to be either acetic acid or the butanoic acid, because those have your pKa values that happen to be the same number, but or at least in the neighborhood of where the midpoint for this guy is. So how are we supposed to figure out which one it is from here? Well, we can use a trick that we learned in a previous portion of this, which is where we can figure out what the molecular weight of the mass is. So remember that the molecular weight is going to be equal to the grams per mole, and I gave you 0.44 grams of the unknown acid earlier in the problem. So this is 0.44 grams. And all I got to do is figure out the number of moles. Well, where does that come from? Well, that comes from the equivalence point here. So knowing that the equivalence point is obviously right at 20, then what we have here is we have 20 milliliters of 0.25 molarity of my strong base. So put it into proper terms, that would be 0.020 liters times that. And so 0.02 liters at 0.25 molarity is going to be 0.005 moles. So at that point, you have 0.005 moles of the hydroxide that was added. And the whole idea of the equivalence point is that at that point, your base and your acid are equal to each other. So that must mean that I have 0.005 moles of my original acid as well. So this is 0.44 grams divided by 0.005 moles. So 0.44 divided by 0.005 means that I have a molar mass in the vicinity of about 88 grams per mole. That is there. So then the question becomes, which of these guys here weighs 88 grams per mole? Well, let's check it out. Acetic acid has a mass of 1 and 24 and 3 and 32. He has a mass of 60 grams per mole if I add this whole formula up. The other guy here has a 48 and a 32 and another 8 is 88. There you go. That's your guy. So the butanoic acid here has the correct mass and it has the correct pKa. So it must be the butanoic acid and not the acetic acid, because all of the evidence points to the butanoic acid being the